The following question reads that PCl5 dissociates as follows. So there's a reaction given PCl5, it's dissociating to form PCl3 and plus Cl2. And the extent of dissociation is 13% at 160 degrees centigrade and 100% at 300 degrees centigrade. So what that basically, this information, what that provides is that if you increase temperature, so you're going from 160 to 300. So if you increase temperature, then what's happening is dissociation increases. 13% was at 160 degrees centigrade and 100% is at 300 degrees centigrade. So if you increase temperature, then the amount of forward reaction or the dissociation increases. So more forward reaction occurs. Now the only way that's possible is that if the forward reaction is endothermic, because endothermic reactions are going to be favored if you increase temperature. Exothermic reactions vice versa are favored if you decrease temperature. So endothermic reactions need energy. If they need energy, they need a higher temperature. So if you increase temperature, endothermic reactions are favored. So one thing is that we have figured out is that the reaction is going to be endothermic. So it's either going to be A or it's going to be C. So these are your two options. The other thing that is being asked is the shape of the molecule of a PCl3 molecule. So if you draw PCl3 phosphorus is making 3 bonds with chlorine, and here's your third bond, and phosphorus has 1 lone pair. Now 1 lone pair and 3 bonds, the shape of the molecule is going to be pyramidal. The 3 chlorine atoms would be arranged in a pyramidal manner with the lone pair sitting at top, and that would be repelling all the 3 bonds downwards. So the shape of the molecule is going to be pyramidal, and the correct option would therefore be, it's going to be option A, because the reaction is endothermic and the shape of the molecule is pyramidal. So option A is the correct option.